Zombie Apocalypse.
Okay, so this time now, let us try to apply yung mga na-discuss nating principle and some code provisions taken from NECP 2015 first printing. So, topic is crack and uncrack station, using the section transformation. So, get ready to be neurorized. Okay, so here is our problem. So, we have this beam, okay? However, it has notch at the top. So, meron siyang triangular notch na makikita. Okay? So, also, you will notice that the FC prime is given, or as I discussed this before, this is what you call the compressive strength of concrete. And some loads are given, no? Dead load and live load. So, dead load is DL and live load is LL. So, dead load as 25.14 and live load is 11.4 kilonewton per meter. Now, notice that the beam that is 400 by 600 mm in dimension has reinforcement, no? 4 pieces of 25 mm diameter, meaning ang isang bilog ng bakal na inilagay is 25 mm, while yung nasa taas ay 3 piraso ng 25 mm diameter. So, the beam is also provided, no? Meron ka ditong overhang na 1 meter sa left side, and given the load W that we are going to identify later, and a concentrated load of 180 kilonewton. Okay? So here are the following questions, no? Letter A, if for us to find first the cracking moment in kilonewton meter, then followed by compressive stress felt by the concrete in megapascal. Okay, tension stress felt by the tension bars, compression stress felt by the compression bars, moment of inertia under critical condition, and as well as the demand capacity ratio of concrete under compression stress. Now, notice that there's a question referring to the bars, no? May tension and compression. Notice that there's also bars, no? But we cannot identify right now sino ang under compression dyan at sino under tension. So, titingnan natin on how do we correctly assess what bar are under compression and what bars are under tension. Okay, let us have a short review of the codes, ano? Now, in our past discussion, in our video lecture prior to this, we have discussed that in NECP 2015, the cracking moment is FRIG over YT, as the equation code 424.2.3.5b is concerned, and under the code provision of the rupture modulus. To get that, knowing 419.2.3 modulus of rupture, so modulus of rupture under that code 0.2.3.1 is taken as 62% or 0.62 of lambda squared of FC prime, where lambda is in accordance with the section that I have discussed before. But notice that there is no mentioned condition of what kind of concrete is being utilized. So the base assumption is it is a normal weight concrete. So that's why we are going to use a base value of lambda that is equal to 1.0. Unless specified of what type of concrete are being used and what type of mixture, no, yung ganyang ginamit. Okay, let's have a short review of the terms and definitions. No, FC prime, specified concrete strength. Okay, F sub R, rupture modulus. I sub CR is referring to the critical moment or the crack and the moment of inertia under crack condition or crack section transformed. And IG represents the gross moment of inertia where the reinforcement are to be neglected. Okay, MA represents the maximum moment, no, found on the beam. M sub CR is the cracking moment, and the Y sub T, no, the distance from the centroidal axis of gross section, neglecting reinforcement to tension phase. Meaning, kapag meron tayong positive moment, okay, understood natin na yan before in theory of structures that compression is above, tension is below, then there should be designation of YT there. However, if we found out that the maximum moment is negative, then it should take the reverse. So this is tension, this is compression, and there's a need for us to calculate what is Y sub T as located at the top fiber of that concrete. Okay, that's the case. Okay, so where do we start the assessment? So let us calculate first no yung mga available loads kasi may binigay na beam dito, and then we have to find out ano yung total W, no? So therefore, by solving this, there's a need for us to calculate first the uniform beam weight or the dead weight imposed by the beam itself or the self mass. So that is calculated as unit weight of concrete times area of the beam. Area of the beam na to, no? Again, under cracking moment, ano? So therefore, that is unit weight of concrete equals 23.544 kilonewton per cubic meter. So actually, this is a constant, eh. So it is actually generated by a density value of concrete said to be 2,400 kilogram per cubic meter. Actually, I will try to re-emphasize this in our next discussion in singular reinforced concrete beam. Okay? Singly reinforced concrete beam. So, may code naman yan na nagpe-prescribe under flexural requirement or flexural, requirement for concrete. Kasi recognize ng code natin that specific gravity of composite concrete is 2.4. Okay, kasama na yung reinforcement. Again, this is only true for normal weight concrete. Then, right now, we don't know if this is crack or uncrack. So, it is safe to assume first to consider uncrack stage. So, meaning, there should be a reference where we are going to take a look. So, therefore, by this, if we are going to assume uncrack stage first, so I think this is a very, or what you call the elementary way of analyzing a concrete beam. If there's no necessity for reinforcement, so as for assessment, then we should say that under uncrack stage, then the cracking moment should be more than or equal to the maximum moment found on the system of load. So also we will recognize that the stronger moment of inertia, I bar x, is also our gross moment of inertia. That is also our cracking moment of inertia or the critical inertia. Okay? So, yung sabi nating stronger moment of inertia, usually kasi ang mga beam natin under normal reinforcement or without reinforcement ay patayo. May reason yan by flexural behavior that we are going to discuss as we proceed, ano? So, the definition is lagi naman patayo ang beam natin. Bihira ang pahiga except for the pre-stress. Depende on the end use, okay? Now, again, I have iterated here to remove all the reinforcement. Kasi, di ba sinabi na code natin, for us to calculate the cracking moment, there is a requirement to assess I sub G and Y sub T to neglect reinforcement. Meaning, we are to deduct the condition of where when we discuss the N-1 times AS, no? If you recall this, under tension. So, we are to remove this since by the code, it was mentioned to remove and neglect the reinforcement under tension. Okay, but of course, for comparison view, you can calculate that one, neglecting the NSCP 2015, but it doesn't offer that you are computed it wrong, no? It is also correct. However, you will show some discrepancy of the answers. Now, in this discussion, I will be following and compliant to what NSCP 2015 is saying about the neglect, the principle of neglecting the reinforcement. Okay? Now, so therefore, as we get, no, ang area of the beam, yung buo, minus the notch, ano? Notch lang naman yung 1/2 of 0.075 by 0.03 in terms of meter, no? Unit compliance tayo, meter tsaka kilonewton dapat. So therefore, we will get a uniform beam weight of 5.624073. Di lahat ko muna siya kasi I want to conserve the value of the answers on A2F. Although you can, as described, ano, feel free to use at least 4 significant digits of decimal kasi andyan talaga ay makikita nyo yung pinaka-accuracy ng mga values. But for the meantime, allow me to get the full value para ma-conserve ko yung values natin mamaya. Okay? So by adding all the loads, so W will be a value of 42.164073 kilonewton per meter. Okay? I added all the dead load, the live load, and the beam weight. Okay? Okay, then followed by the drawing of the shear and moment diagram that I know that you're already aware. As your lecturer, I am assuming that the learners are already aware of their strength of materials course regarding how to draw a correct shear and moment diagram. Okay? So by this, let us try to get the maximum moment, and then you will notice that the maximum behavior will act on the positive 401.628095 kilonewton meters. That's why we declare that the maximum moment is equal to m sub a equals positive 401.62895 kilonewton meter. What does a positive moment maximum means? Meaning the deflection on that particular, or rather the bending suggests that the moment is under positive. Therefore, we are aware, and I discussed earlier, that the compression is found above and tension is found below. This is very essential in identifying where to correctly locate y sub t in our calculation of the cracking moment. Okay? Now let's proceed with the next calculation. Let's have this cross-sectional area. So what you're seeing, I have removed this reinforcement. Okay? And you are aware that under positive bending, compression is above the neutral axis and tension is located below the neutral axis. Now, let us try to calculate the area. So this is actually the same area that we have multiplied to the unit weight of concrete to produce the beam weight. But this unit is in terms of square millimeter. Okay, so that to make some precise calculation for us to proceed. And then using Varigno's theorem, again, as your lecturer, I am assuming that you're already aware of what you have learned from your strength of materials in statics in calculating the centroid. No, my main objective is to get y sub t. So what I have done here is I set a base reference at the bottom. The way the statics are discussing this, okay, this is my plane reference. Or it's up to you to place wherever you want, no, but as long as we will get the same answer. So my YT is 298.6342, and I get the other side under compression, that is 600, okay, minus y sub t, that is 301.3658 millimeters. Also learned from statics, I need to get the inertia of the stronger axis, I bar x, since this is actually the execution of the inertia, no, along the x-axis or about the x-axis. That's why I bar x will now be the representation of the gross moment of inertia where reinforcement are to be neglected. So by this, I think you're aware that I can do this way, ano? So lahat yan papupunta sa neutral axis. So I assume that there is a full rectangle, and then followed by deduction of this triangular area. Ito to, yan yung shinadan ko na violet. So my main objective is to project all of it, no, papunta dun sa neutral axis. Okay? So yan ang mangyayari. Now you will notice that I will have a distance of the neutral axis as if rectangular up to the true neutral axis, that is 1.3658, while the triangular is away from the neutral axis by the value of 291.3658. How do we get that for a certain review? So I get 1.3658 by getting half of the full rectangular, which is 300, minus the distance YT. Okay? While I get the 291 by getting 600 minus YT. Total, nasa taas naman siya. And then this is deductible by a value of 30 over 3, y 30 over 3. Kasi pwede ko naman kukunin ito munang buo, then ibawas ko yung centroid nito, okay? For me to get this distance. Where in a triangle, we are aware that this is the 1/3 of the height, okay? Assuming that this is the height, okay? So the remaining is 2/3. So that is already oriented by you in your geometry. That's why you will get this value. I sub G is 7,104.8857 times 10 to the 6 millimeters to the fourth. Now, after obtaining I sub G, or the gross moment of inertia, we are now ready to calculate the cracking moment. So, the calculation that M sub CR is equal to FRIG over YT, where F sub R, let us plug in all of the formulas required, where F sub R, or the rupture modulus, is taken as 0.62 of lambda squared of FC prime. Again, we will take lambda as 1.0. Again, for what particular reason? As normal weight concrete as the default condition, other than Other than it, let us try to calculate the true value of lambda as per discussion of the code. Okay, so notice that tinatabi lang natin dito yung mga values para progressive yung pag-idealize ng mga calculation. Okay? Now, to get the cracking moment, just plug it in lahat ng mga values. So, ito yung IG natin, kanina na-compute. Tsaka, ito yung YT, yung 298.6042. Why is there a 1,000 squared divisor? Kasi notice that the unit of, as discussed, FR is in terms of megapascal. Okay? And we are aware that in 1 megapascal, there is a 1 Newton per square millimeter. Multiply by millimeter to the fourth, the resulting unit at the top is Newton per square millimeter, okay, by millimeter to the fourth, no? Divided by millimeter, okay? So meaning the final unit would be Newton millimeter. My desired unit is in terms of kilonewton meter. That's why if I convert it, 1,000 for Newton to kilonewton and 1,000 for millimeter to meter. Okay, that's why we got the cracking moment of 77.3527 kilonewton meter. And that satisfies the answer of the question letter A. What's the cracking moment in kilonewton meter? Now, notice that our maximum moment is 401.62895 or about 629. 401.629 kilonewton meter. And the capacity to resist crack only is just only 77. It is pretty obvious that it is said here that the cracking moment is way less than the maximum moment. Therefore, our assumption is wrong. Then it should be an uncracked beam, and then we cannot say that the cracking inertia or the inertia under the crack condition is equal to IG, but this is now not equal to the gross moment of inertia. So there is a value, true value for I sub CR to look at. No? So therefore, we cannot say that this is IG. Ngayon, kunwari lang naman, na nagkaroon ng, kunwari, nag-calculate ka, no, M cracking mo, is this value, tapos, mas mataas pa sa maximum moment, let's say, no? Kasi nakuha mo ditong MA, kunwari lang naman, 70 kilonewton meter, ibig sabihin, kaya-kaya ng beam, no? Na mag-resist. So therefore, walang necessity sa reinforcement kapag cracking moment is more than MA, no? Ito. So therefore, what can you say about the moment of inertia under the critical condition, the cracking moment? So I sub CR mo is already IG, no? As mentioned on the discussion before. So therefore, you just answer it by giving that value. Ngayon, kung nagtuloy-tuloy, let's say talaga naging uncracked. So what are the possible answers to the other question? Most likely, compressive stress, okay, felt by concrete is the same, FC. Okay? And then, the tension stress felt by the tension bars is 0. Compression bar is 0. And the demand capacity ratio under compression stress is 1.0. Itong mga set ng answer na pinapakita ko sa inyo na FC, okay, kung makukuha nyo man, as FC prime, okay? Yan na rin sagot yan. If and only if you are under the condition of what? Uncrack, no? This is for uncrack. So, ito yung mga sagot natin, sana. Okay? Ito kasi magiging IG ito, no? Yan. Kapag ito ay sana ay uncrack. Malinaw, ano? Hindi, no? What happened here is under crack beam, meaning there are values existing for those answers, for those questions. Okay, that's why we consider the next condition where the crack stage follows. Now we need to convert all the strength of concrete as base material. Use modular ratio to convert. Now there's a need for us to round up to the next whole number. The logic is there's no such thing as half of a strength. Okay, half of a piece. So there should be a whole of a piece. And based on your strength of materials, it is the steel modulus, okay, over the concrete modulus. So it is taken as 200,000 megapascal, okay, unit niyan. And in our code, I will show you next meeting or next discussion that this is for the E sub C under normal weight, no? For normal weight. Okay? So, pag-isahin ko na lang i-discuss yan, but for the meantime, let me present this to you. This is very vital. So, 4,700 square root of FC prime, where FC prime is always in terms of megapascal. And the product of E sub C is also in terms of megapascal if you use that formula. Okay, so therefore, you found out that the modular ratio N is 8.1146. So, there's a need to round it up. Kahit anong value nito, you always round it up. So, make it 9 for theoretical purposes calculation. But of course, in practical, tinitingnan, let's say, may nakuha ka, no, 9.08. So, it's up to you to make use of 9 or 10. But of course, in theoretical muna, let us use the concept of rounding up principle, regardless of the decimal found on the value. For value engineering, pwede ka mag-isip ng gano'n na, let's say 9.003, then use 9. Okay? Pero sa atin, we are always going to round it up. Okay, so what follows the calculation? So let's say we install again the beam reinforcement. Notice that earlier we already found out that is at the top of the neutral axis is compression and the bottom is tension. So meaning the bars here are what we call compression bars. Ganun na po, ano? And then the bars at the tension at the bottom side is what we call the tension bars. Okay? So para identify nyo, hindi lagi sa baba ang tension bar, depende ano yung nature ng bending. Okay, so if meron tayong negative bending, then kung negative bending ang meron tayo, then it should be tension above, compression below. So tension bar sa yung taas at compression bar yung baba. Okay. However, we have positive bending as we identified as positive 401.6 to 1895. Therefore, we already know the nature of the bars. Okay, by this. Okay, what you're seeing here is what we call the transform section. So what we're doing here is to get and idealize the code. In our past video lecture, we have discussed that there are two types of crack, no? I mean, there are two stages of cracking. One is underlinear muna, no? Underlinear stage. So there's what you call non-crack linear stage and crack linear stage. Yung kanina na inassume nating M sub CR that is more than MA, ano? Okay, yung kanina, we assume non-crack. Okay? Or uncrack. Then linear or code-based tayo, ha? Linear base, no? And then, kapag ka nagkaroon ka na M sub CR na nag less than, okay, isama natin equal yan. Okay? That is MA, meaning this is now the what we call crack linear base. Okay? So therefore, under crack linear base, from the term linear, we expect that the stresses is under linear. O, yun muna nang i-explain ko dyan. But here is very important. How do we use that? Ina-assume kasi ng crack na yung tension side is natatanggal na. Mark in violet, i-assume nyo po na wala na pong concrete dito. Ang nakikita nyo lang, yung bakal na 4 na pirasong 25. Perforated na sa nangyayari ngayon by this analysis. So parang wala nang silbi siya for tension, no? As mentioned by the code, no? Neglecting the concrete itself, no? Under crack. Okay? So therefore, ang mag-act na lang dito, kung napapasin nyo, nawawala na yung concrete under tension, no? Putol. Okay, nawawala na yan. Non-functional. So, ano to nakikita nyo mahabang area? Yan yung representation ng modular ratio. Dahil bakal ito mamarkahan ko ng red. So, we are converting the stronger material into a weaker material para maging homogeneous yung analysis natin. Okay? So, therefore, under tension, unahin natin yung under tension. Yan. So, therefore, ito yung equivalent, no? And that is N times AS. Modular ratio times area of the steel. Total steel area. Under tension lang. Pero pagdating sa compression, pag may compression na, then you have to multiply it by 2N minus 1. Yung AS prime. Note that AS prime designates compression bar. Okay? Compression bars. While AS Now, I'll try to mark it red para medyo makita. Ayan. Okay, AS represents tension. So, rule of thumb usually sa RCD, kapag may nakita kayong prime or yung prime na kuwit sa taas ng letra, that is what we call for compression most of the time. Okay, we are going to use that the same here as the code suggests. So therefore, by this, then the reason why it is n times AS, kasi nga, pinalalaki natin, pinahihina natin yung malakas. Bakit 2n minus 1? Kasi may concrete ka pa dito. Don't forget, no? May concrete ka pa dito na nag-act, kaya babawasan natin ang area of the same steel bar. Kasi may dinisplay sa bakal dyan, di ba? May butas na ginawa dyan, under the concrete region for compression. So, totally, may nawalang force pagdating dun sa concrete compression. So, therefore, we need to deduct it by 1. Kaya 2n minus 1. Bakit times 2? Equal kasing area na nawala at saka yung inilagay. Okay? Kaya na yung short explanation yan. Okay. So, what do we need? Now, let us set up what we call defective depth D. Yan. Yung D, next time, i-explain natin by the code again na kinakompute yan from the start. Ano? While for the meantime, let us accept that it is D. So, what is the effective depth D? Where you are going to compute 600 minus 50. Ganun lang kasimple. Kasi this is 50, the total height is 600, so you just deduct. Okay, then calculate 2n minus 1, NAS, pala muna, is equal to 9 as dn. Ang steel area mo, no, is, meron kang 4 pieces na isang area ng bakal na pi over 4 times 25 squared. Okay? Bilog So, this is the diameter. And you know that the area of a circle is pi over 4 d squared. And then, multiply by n for the number of pieces if there are more than 1, of course. And then, and let it be the modular ratio as we calculate as almost equivalent to 9. So, you will get 5,625 pi of a millimeter squared. Likewise, you're going to do the same. So, ganun din po, si 2n minus 1 AS prime, where AS prime is pi over 4, okay, times 25 squared. Kasi yung bakal sa compression mo, 3 piraso na 25 mm squared. Sa tension naman kasi is 4. Kaya nandun yun, okay? Ito naman para dito. So, therefore, we will get 31,875 pi over 4 mm squared. Sinecure ko muna yung value ng pi para medyo conservative sa mga final results. Okay, so what we're going to do is now assume the location of the neutral axis. Okay, so this is the neutral axis. So my assumption is I put here as a distance of x. So ito yung distance of x ko. Okay, at pinalagpas ko siya sa compression bar. So therefore there can be an assumption to be checked. Now I assume that my x is more than 65. 65 plus 725 over 2 kasi may kalahati pa yung bakal mo, no? Kailangan lagpas talaga dito muna. That's why I let x to be more than 77.5. That distance x is the distance or the height of the compression region. Kasi ito yung compression concrete natin. Ito yung tension side natin. So therefore, kailangan mag-assume kasi hindi po pwedeng nandito yung neutral axis mo. Tanda mo, pag nasa baba ng tension, ng neutral axis, magiging tension, di ba? Under passive bending. So, sabihin, itong dalawang bakal na to, magiging tension, which is wrong. Okay? So, that is not possible. Okay? So, therefore, I need to assess that the tension, the distance x is more than the rebar compression distance. No? That's why I add 25 over 2. And then, I set moment at the neutral axis equal to 0, and then c is equal to t. Ipo-prove natin bakit c is always equal to t, no? So, ganito mangyari. Mapapansin niyo na kinuha ko muna yung area ng concrete. Okay? Let us take this step by step para hindi malito. Kunin mo muna yung area ng concrete na nasa compression, i-transcribe mo doon. Okay? Kaya ito siya. Yan. May bakal ka na 3 piraso. Ito. Yan. I-transcribe mo doon. Okay? Kaya merong humaba. Para ano to gabuhok lang po ito na 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 kanipis tapos sobrang haba. Okay? Ganun din po dito sa may tension. Okay, no? Ito to, yan. I-transcribe mo doon, hahaba din siya. Okay? Na ito yung value. Ayan. Okay? Now, so, ang gagawin natin, papupuntahin natin neutral axis lahat ng distances. Okay? Pati ito. Yan. Kaya C is equal to T. Okay? Then, how do we get this? In-assume ko muna, dahil may uka, parang ang itong area na to for me is equal yan sa buo, then minus sa uka. Okay? So, pwede naman, kung gugustuhin ninyo, pwede naman ganito, maraming way, is equal to, putol-putulin mo yung area kung gugustuhin mo. Ito muna, plus nito, plus nung nasa taas. Okay. It's up to you. It will give us the same answer din naman. Okay? Ngayon, let us proceed. Now, you will notice that this one is the area as if buong rectangle. Minus, bakit minus? Kasi bawasan mo yung area. Okay? Ito yung area nung notch na triangle, and then this is x minus 30 over 3. Ito siya, yan yung uka na to. Yan, papupuntay mo dito. Kasi ito, 1/3 ito of what? No, 1/3 of distance height 30. X yung total height. So minus yung 1/3 of 30 sa x. Okay? Para malinaw. And then plus. Bakit plus ito? Then may bakal diyan na compression. Kapag walang tension, pag walang compression ba, let's say ito, wala ito. Wala sa given yan. Di wag niyong gamitin to, tanggalin mo na sa equation. Pag present yan, di dapat ilagay mo siya. Okay? Ganun na yung presence niya. Now, so, let me erase this a little para malinaw-linaw. Ayan. Now, so therefore, wala po siyang, what do you call this? Direct influence dun sa area kasi ito yung totoong area na ng force, no? That's why, area of this bar is 2n minus 1 times AS prime. This is, we calculated it earlier. And then, times the distance of x minus 65. So, 65 millimeter, no? Yung binigay na distance. X ito. Okay? So, distance mo makukuha na ito. X minus 65. Ganun na siya ka-bilis kunin. And then, followed by equal. So, equals na kasi tapos ka na sa compression eh. Sa tension ka naman mag-equate. Okay? So, sa tension, NAS lang yon times D minus X. So, N minus A, N times AS multiplied by D minus X as a distance going to neutral axis. Okay? So, that's why, as you plug all the values, you will get 155.8216 tsaka negative 363. So again, we cannot accept negative distance. And then as we check kung tama kaya ating condition, if x is 155.8216, more than 77.5, so therefore okay. What if hindi? Kunwari, ito yung 160. Okay? 155 nakuha mo, so more than yung 160. Let's say, kunwari, ito yung 165. For example, na hindi siya 160. Sabi natin, 165. Ayan. What can you say? Ibig sabihin, mali yung assumption. So, therefore, there should be a recalculation. So, meaning, mali yung naging checking mo. Okay? So, therefore, you have to recalculate your assumption. Okay? Your calculation based on your assumption. But usually, this will fall under to a correct condition. Okay? Kasi ang bakal mo naman, sobrang lapit sa compression maximum fiber stress. So, using the inertia, so ganun po ulit. So, BH cube over 12 for the full rectangular plus height plus the area times the distance going to the centroid, which is x over 2 lang din naman. Yan yun. Then, may notch ka na minus. Ito, yung triangular. Yan. Shaded in red. So, minus 75 30 cube over 36. Alam niyo ba 36? Kasi triangle yan. And then, minus ulit ng area. And then the distance, so x minus 10 squared, o ba't x minus 10? 30 over 3 is 10. Plus, ito po yung 2n minus 1 as prime times the distance raised to 2. Bakit wala siyang BHQ over 12? Recall that ito'y gasing nipis ng buhok ang kanyang area. So, yung kanyang cross-sectional area. Meaning, tolerable or negligible na. Negligible na yung kanyang centroidal inertia. So therefore, drop that and then just adapt AD squared. Tandaan nyo to, transfer of inertia lang ito, no? Na kinagamit lang yung naaral natin sa statics before, that Ix is equal to I bar x, okay, plus A dy squared. Siyempre, meron siya tinatawag na sigma notation. Summation yan. Okay? So, ganun din yung sa tension, plus na lang. Tandaan nyo, additive na po lahat ng compression, okay? At saka si tension. Kasi isang inertia lang yung kinakalculate mo, no? Kung parang procedure na lang ito na statics na kahit nasa taas o nasa baba, you just add. Pero pag deductible yung area, saka ka magbabawas, katulad nung nangyari dito. Okay? So, madali lang ito, statics. So, therefore, we got critical inertia is 3,432.7065 times 10 to the 6 mm to the fourth. Kung naalala ninyo, in my past video lecture, we have mentioned that kapag nagiging crack ang uncracked beam, we always expect, most of the time, malaking chance that the I critical is less than IG. And that proves this condition where IG kanina is around 7,104. Anong logic behind? Tandaan nyo kanina, yung YT natin is around 298. So therefore, 301 naman yung YC kung tawagin na nasa taas. Kasi ito yung YC. Let YC be the X distance. So therefore, nag-shift siya pataas ang neutral axis mo. Yan ang behavior ng changes from uncrack to crack. So from uncrack to crack, okay, ang nature is lumiliit yung cracking inertia. Okay, tinatawag natin critical inertia. Tapos, yung ating X or yung YC is magiging paliit naman. Kasi around, this is only 155. Kanina, 300 plus yan. Nung nasa uncrack stage yan, no? Yan yung correlation. So, that is the answer, no? Moment of inertia under the critical condition or under the crack condition. Now, let's take a look on how do we calculate stress. So, sinabi naman ng stress is linear pa rin distribution kasi na under tayo ng tinatawag na crack na linear stage. Okay? No, crack linear stage. So, therefore, FC. And then, notice that the Fs prime, no, kakahilera nito, hindi siya 2n minus 1. Bakit 2n? Kasi we're talking about stress, not the area itself. So, therefore, 2n lang. So, while on the Fs, so over n. Kasi sa totoo silang talaga malaki yan eh. Malaki talaga to eh, no? So, ganyan, sign convention nga pala, kapag compression going to the left tayo, or negative, kapag tension going to the right, positive. Okay? Kaya that's why compression yung taas, no? Kaya mapapasin niyo ang aking arrowhead is going to the left. Kasi compression. Tension naman is going to the right yung arrowhead. Okay? Yan. Now, so therefore, as we continue, note that the bending stress F is equal to my over the I, where m plays the maximum moment, y is the distance of that particular point up to the neutral axis, as described by strength of materials, and the I as the moment of inertia. Now, replacing that, ito po yung mangyayari. Bakit x yan? Kasi the distance of FC, yung nasa taas, yung pinakatuktok, is distance of x. Okay? So, therefore, gawin natin, medyo i-describe pa natin siya. Total linear na, no? Let K be the ratio of the maximum moment and the cracking inertia. So, bakit ako nag-introduce sa 1,000 squared? Note that this is in terms of kilonewton meter in moment. My main objective is to convert this into a similar unit of Newton and millimeter para madalian ako mag-interpret ng megapascal. So, ibabalik ko na siya sa Newton and millimeter units. So, there should be conversion. Bakit 1,000 squared? In 1 kilonewton, there are 1,000 Newton. Okay? So, 1,000. And then, another 1,000. Okay? So, kaya 1,000 squared. Then, that is taken as 0.117 para ito yung constant. To simplify, say FC is equal to Kx na lang, so where X is calculated earlier, and then we can say that FC is 18.2312 megapascal. Okay? And that answers letter B already. Ulitin ko, kapag crack, ito yung sagot niya. Pero pag uncrack yan, sagot niyan is 0. The answer is just only the same answer with FC prime. So 27.5 megapascal if that is uncracked. Nag-crack. We expect that value na may ibang value na lalabas. Okay, also, if Fm is equal to MC over Di, so therefore, kung pinahina mo siya, ibalik mo siya sa pagiging malakas, i-divide mo siya sa kanyang sariling modular ratio. So, ganun ang rule of thumb. Okay? So, you're talking about Fs, so meaning, andito siya sa baba. Okay? Fs over N, huwag niyo po alisin yung N dyan sa ilalim ng Fs, kasi binabalik ko na siya sa pagiging malakas na stress, is equal to Ma over ICR. So, note that this is also K, ano? Bakit D minus X? Ito yung distance kasi niya. D minus X naman, away from neutral axis. May X value ka na, may D ka na. So, we can now calculate. So, magiging NK 50 minus X. So, therefore, we can have Fs of 415.0722 megapascal. So, that answers letter C. Again, pag ito ay crack, ito yung sagot, no? 415. Pero pag this is uncracked, the answer should be 0. Kasi walang bakal na nag-exist. Likewise, no, and Fs prime or compression steel bar, okay, this is this one. O bakit over 2n? Binabalik natin sa pagiging malakas kasi meron dalawang butas na natanggal. At na-involve. Isang natanggal, isang bumalik. But we are not referring to displaced area. Displaced strength naman tayo dito. Displaced stress. So therefore, over 2n lang. Kapag tension, over n. Kapag compression, over 2n. Okay? Para malinaw lang. So, therefore, doing the same, so magiging KD naman ito, yan, para madali, linear value, 2nk x minus 65. Kasi 65 ito yung distansya niya, no? Ito, yan, this is x, no? Minus 65. Kasi this is 65, ano? Kanina binigay. Okay? And then this is x. Okay? So, therefore, we can now have 191.271 for megapascal. That answers letter D. Ulitin ko, pag ito ay crack, yan ang sagot. Pero pag uncrack, it should be 0 also. So, therefore, to finalize the remaining question, so demand capacity ratio under compression stress, or we can say that this is also compression ratio. Okay? So, this can be also termed as compression ratio. So, the compression ratio or the demand capacity ratio under compression stress is given by FC over FC prime. FC prime is given 27.5. We have calculated just before this 18.2312 for FC, and then we will have 0.663 as our demand capacity ratio. Ano ba ibig sabihin ng 0.663? Meaning, to take a look that FC is equal to the DCR under compression times FC prime, meaning this is the utilization of the percentage value. So meaning we have used only 66.3% of the strength available for that particular concrete beam. So yan ang ibig sabihin yan. Okay, so thanks for viewing. So next discussion, I'll try to solve this problem again, but this time, gusto ko makita naman ninyo na kung meron kang compression stress at tension stress, meron din kinatawag na compression force at tension force. Paano ba natin kinakalculate yan? So, let us try to find out. So, again, thanks for viewing. I hope that we will see each other in the next video lecture. I will try to show how to calculate compression force and tension force in a crack and uncracked beam. Okay? So therefore, you have been neurorized, and see you in our next video lecture.